Hello everyone, welcome to my channel Srihari Science Classes. In this class, I am going to introduce one of the topic for you, that is Oxo Acids of Halogens. Halogens with the oxygen, there forms four types of oxo acids. They are halic 1 acid. Its another name is Hypochlorous acid. Next acid is halic 3 acid. Its another name Halous acid. Next one halic 5 acid. Its another name halic acid. Another halic 7 acid. This is the last one. Its another name is perhalic acid. Here I am written in the bracket with Roman numbers 1, 3, 5, 7. They indicates the oxidation numbers of the halogens. So halogens, fluorine, chlorine, bromine, iodine. The last element is astatine. That is a radioactive element that doesn't forms any these kind of substances or the products. So now about the fluorine. So fluorine forms only one type of oxo acid, that is HOF, hypochlorous acid. It doesn't form another three types of oxo acids. Next one is about the chlorine. It forms four types of oxo acids. They are HOCl, hypochlorous acid, HOClO, chlorous acid, HOClO2, chloric acid, HOClO3, perchloric acid. So these are the four types of oxo acids formed by the chlorine. Next element is the bromine. It forms only three types of oxo acids. They are HOBr, hypobromous acid, HOBrO2, bromic acid, HOBrO3, perbromic acid. And next about the iodine. It also forms only three types of oxo acids. They are HOI, hypoiodous acid, HOIO2, iodic acid, HOIO3, periodic acid. So these are about the oxo acids of halogens. So in our secondary intermediate syllabus, so we will discuss about the oxo acids of chlorine only. Now I am explaining about the structures of these oxo acids and acidic strength or acidic character of these oxo acids also. Now the structures of oxo acids of chlorine. So first one is the Hypochlorous acid. So central atom is the chlorine. There are three lone pairs at the chlorine. Another bond with the oxygen. So this is about the structure of hypochlorous acid. With the consideration of these three lone pairs, straightly we can say it has the structure of tetrahedral. And so chlorine in the valence shell 7 electrons are there, 2, 4, 6. Another electron that is participated in the bond with the oxygen. That is about the structure of HOCl, hypochlorous acid. So next one is about the structure of chlorous acid. Again central atom is the chlorine. Now the structure is oxygen. So OH is there. This is the lone pair. And here the double bond. Here another lone pair. That is about the structure of chlorous acid. Again, so with the consideration of two lone pairs, the molecular shape is the tetrahedral. Without these consideration, the molecular shape is the angular. And the next one is third one, that is the chloric acid. So again central atom is the chlorine. Now one lone pair. So here the one oxygen, double bond, here the another oxygen, another one with single bond with the hydrogen. That is about the structure of chloric acid. So with the consideration of this lone pair, we can say tetrahedral shape. Without this, it has the pyramidal structure. That is about the structure of chloric acid. Next fourth one is the perchloric acid. Central atom is the chlorine. and there are 4 oxygens, 3 are bonded with double bonds, another one with the single bond. OH is there. So this is about the structure of HOClO3 perchloric acid. In each and every structure, central atom is the chlorine, and with the concentration of lone pairs, so all the structures are have the tetrahedral shapes. This is about the structure of oxo acids of chlorine. Now about the acidic character, acidic nature I am saying. So order of acidic strength of oxo acids of chlorine, HOCl is less than, HOClO is less than, HOClO2 is less than, HOClO3. That is the order of acidic nature of oxo acids of chlorine. So that is because, observe here, in the case of this, there are 3 oxygens bonded with the double bonds. So as compared to chlorine, oxygens have the more electronegativity, accepts the bond pair, accepts the bond pair, accepts the bond pair according to electronegativity. So that's why at the chlorine, electron density completely reduces. That's why it is trying to accept this bond pair towards its side. Now the release of H plus that easily takes place. That's why it is a strong acid. As compared to this, here only 2 oxygens are bonded with double bonds. So attracting nature somewhat less in this molecule than this. And as compared to this, only 1 oxygen bonded with the chlorine with a double bond. So bond pair attraction in this molecule somewhat less than this. And then here there is no oxygen atoms bonded with the double bonds. So only the chlorine has to attract this electrons towards its side. So that's why H plus release occurs. So as compared to these are all 3, it contains very less acidic character. So because release of H plus takes some time, that is the reason of acidic strength. And the next one, for example, if I am taken the different types of oxo acids of different elements, that is HOCl is greater than HOBr is greater than HOI. It is due to, so from fluorine, chlorine and bromine, iodine, so from fluorine to iodine, electronegativity decreases. Due to decrease in the electronegativities of halogens from chlorine to iodine, the acidic strength of these oxo acids of halogens also decreases. So among these 3, HOCl has more acidic character. This is about the oxo acids of halogens and especially oxo acids of chlorine, their structures and their acidic nature or the strength.